Good morning, one and all. On behalf of St. Mother Teresa Engineering College Management, Principal, Staff and Students, I am happy to provide welcome address to this webinar on dynamic routing using Cisco Packet Tracer. First of all, I thank Lord Almighty for providing this opportunity. Particularly, I welcome our resource person, Speaker Dr. J. Immanuel Johnraja, Associate Professor and Head of Computer Science and Engineering, Karunya Institute of Technology and Science, Coimbatore. He received his bachelor degree in engineering in 2003 from MS University. He received his master degree in engineering in 2005 from Anna University, Chennai. He received his Doctor of Philosophy degree from Karunya Institute of Technology and Science, India during 2017. He has 15 years of experience in teaching. He has published several papers in journals of international repute. His areas of research include mobile ad hoc network security, routing and vehicular ad hoc networking. He has been the instructor of and the course coordinator of Cisco Certified Network Associate course in Cisco Networking Academy, Karunya University since 2007. He was one of the CCNP instructors recognized by Cisco Systems, Bangalore. He is a recipient of Advanced Level Instructor Excellence Award from Cisco Systems for 4 consecutive years, 2017 to 2020. With such a person, we are happy to have for the occasion of this webinar. Also, I welcome all the participants in and around India. And now I hand over the session to Dr. J. Immanuel Johnraja, sir. Thank you very much.
Thank you, Asir, for the nice introduction. I sincerely thank the administration and the management of St. Mother Teresa Engineering College for having given me this opportunity to share my little knowledge with the students and the participants on the dynamic routing using Cisco Packet Tracer. So the tool which I am going to use is Cisco Packet Tracer, and many of you might be aware of this tool, and you may be using in your laptop or desktop or even in your mobile device. This is a tool which is a simulator tool. So this is not an emulator, or no, you will not be able to connect with the real routers and the switches. So I would recommend you, the learning community, to make use of this tool for your own benefit. Now I take you around this particular tool. Hope you are able to see this particular software of Cisco Packet Tracer. And the version which I am using is version 7.3.0.0838. This version of tool is at present available to the candidates of Cisco Networking Academy, but anyone who wants to use this tool can download the early versions of this tool from the Google Play Store for the mobile app, and also from the internet for their own use. So this specific tool will really lure you to learn towards the networking side.
இப்போ தெரியுது.
Asir, whether the screen is visible to you?
Sir, now it is visible.
Visible?
Yes, sir. Now it is visible.
So I can go ahead.
Yes, sir. Yes, sir.
All right. So thank you.
Right, sir. Okay, sir.
Thank you. Thank you. Yeah. So let me introduce you this tool. And the lowest side, the left-hand side, you could see all the necessary end devices, the intermediate devices, all the connectors which are labeled. I'll take you through various devices. You got the switches and the routers, hubs available under the network device. End devices are numerous. You got PC, laptop, server, IP phone, VIP devices, other televisions, IPTV, and other devices are end devices are available, and also IoT components, MCU boards are available for anyone to learn and use. Various sensors are available. You can explore it further, and the different connectors which are connecting the end devices with the intermediate devices are available. So the opportunity is huge. So during this lockdown period, and we all are held up in our houses, not able to move to our workplace, or rather not able to move to the academic institutions. So I would invite you to make use of this tool heavily to enhance your learning and networking skills. So this will be a very good tool for those who are aspiring to take up CCNA or CCNP courses. And the latest course which are coming out of Cisco is DevNet. So I would recommend anyone who wants to lay their path towards the networking career, I would recommend you to take up these courses and make this time of pandemic or the lockdown period very useful by upskilling yourself in this networking area. So without taking much time, let me get into the agenda today. I'll tell you how I have structured this presentation. So we'll start connecting the end devices, slowly building up a local area network, and then another local area network, connect them through wide area network technology, WAN technology, and then try to talk to these devices end to end. Are they able to talk? Where could be the problem? How can we configure the basic DNS or the HTTP service, and how the web request is going and coming back, and how the routing is happening among these devices. So I'll try my best to squeeze all this stuff within the time frame which is given to me. So I'll take you around. So when you talk about the networking, you need at least 2 devices. All right, it could be 2 end devices, and they could be connected directly, or they can be connected through an intermediate device. And the third component which is required for networking is your connectors, or in other words, their cables, or the media, in other words. So for that, I go to the end devices first, and I take a PC. Yes, I have brought in a personal computer here, and another end device, another PC is placed. Now let me try to connect these two. These two can be connected using a P2P network, peer-to-peer or ad hoc network. But I'm going to use a switch to connect these 2 devices, because switch is the intermediate device. For that, I go for this PT switch. So there is no such PT switch in the real world, but it is used in the packet tracer just to simulate certain things. Anyone who is very specific in using a certain model of the switch, you can go for 2960 or other switches which are available or which can be configured. All right. Now I have taken 2 end devices and I have brought in 1 intermediate device. And these 3 have to be interconnected. In other words, this personal computer is to be connected to the switch, and another PC is also going to be connected to the switch, forming this as the local area network. So how can I go for it? Yes, I need the cables. As a naive user, or if you are using the packet tracer for the first time, or it is the initial stage of your networking domain, I would recommend you to use this automatically choose connection type, because there are a variety of cables. For instance, this is a console cable used to connect or configure your routers and the switches for the first time. The console cable will have 2 ends. One end will be connected with the console port of your intermediate device, and the other end will be connected to the RS-232 port of your end device for the configuration purpose. Then you can use the putty tool or any other third-party tool, or the Windows default tool to connect with that, like a hyper terminal tool will be helping you to connect with the intermediate device and start configuring. So that's the use of console cable. So that will not help you to have your IP connectivity. Moving on, you got this straight through cable. Straight through cables are used in specific area. For example, if you want to connect a switch with the router or a switch with the personal computer or the end device, we'll go for this straight through cable. The next one is the crossover cable. Crossover cables are used to connect the devices of same layers. I'll demonstrate to you. I take a crossover cable and I connect the fast Ethernet port of this one, and I can connect to the fast Ethernet port of this. Now this cable is used here. However, our objective is to connect this PC with this switch and then this PC with this switch. So how can I remove this cable? Packet tracer will have an opportunity to remove this one. How can I do that? Can I delete it? Yes, I can delete this. So I go for automatically choose connection type to start with. So I go for the connection between this PC and the switch. You could see there is a green color, light glowing, and amber color. Amber color shows that this machine is getting booting up. All right. So again, this PC is again connected to the switch. What is that, sir? What do you talk about this connection? How is it connected? So to understand that more, I take you to the getting into the switch. All right. So this is the physical layout of a switch, and I still zoom in. Hope this is visible to you. On this, you could see there are 4 fast Ethernet ports are available. Console cable, auxiliary cables are available. There is a switch. So this switch will switch on and switch off. So once power is given to the switch, and it is going to go for its own booting up process, and all these interfaces are going to be used for connectivity with the end devices. So this is one of the interface. Could be fast Ethernet 00, 01, 10, 11. All right. So there are 4 interfaces which are available in this specific switch. And when you look at the computer, this PC also has its own Ethernet port. Is it available in the physical mode? I think it should be available, but I don't think whether it is visible. Yeah, it's here. All right. So you got your fast Ethernet port available here. So this fast Ethernet port of this machine and the fast Ethernet port which you have seen in this switch, they will be interconnected using the cable. This is the crossover cable. I'm sorry, this is a straight through cable. Now, how can we check whether these 2 machines can talk to each other? For that, we need to give the IP address. To start with, let me give an IP address to this machine and another IP address to this machine. So what could be my IP address? I place a small note here. I'm going to give 192.168.1.1. It's an IP address. And the mask is 255.255.255.0. Now, please remember, I am assuming that you know the fundamentals of these IP addresses, and I'm not spending a lot of time in teaching you or sharing with you what is an IP address. So I have straight away jumped into it. So 192.168.1.2. I cannot give 1.1 because another laptop here or another end device here is assigned with 1.1. So if I give another machine 1.1 in the same network, there will be an IP conflict. Hence, I go for another class C private IP. So mask is 255.255.255.0. Is it the way to assign IP address? No, this is not a way to assign IP address, but no, I'm just telling these are the IP addresses we are going to assign. So I go to this machine. All right. So how can I assign IP address to this? I go to the desktop. In the desktop, I have something called IP configuration. All right. So in the IP configuration, I give the IP address. So I give 192.168.1.1. And the subnet mask is assigned default because it's the class C IP, which is assigned with the default class C IP. So the configuration is done in this machine. I go to this machine and I use command prompt. In the command prompt, I'm going to use the ping command. So a ping command is very, very popular among us. So I use ping. What is the other IP? 192.168.1.2. And as soon as I press enter, what do you think will appear on the screen? All right, we'll see what comes. Is it positive? Or we are waiting whether something is happening. No, nothing is happening. It says request timed out. We'll see. We'll wait for another moment. No, nothing is happening. So I stop it. I'm not going to wait. It says packet loss is 100%. What could be the problem? What could be the problem? If you see this is assign IP address, bring the cursor over it. It says it is 192.168.1.1/24. No, 255.255.250 is given as /24. This is perfect. But come to this machine, is it having IP address? No, this machine is not assigned IP address by us. All right, let's assign IP address to this machine as well. So we'll go to desktop. Let's choose IP configuration, give IP address. So 192.168.1.2 and the mask is 255.255.255.0. Done. Now, is it assign IP address? Yes, it is 192.168.1.2. Now let's go back to this machine go to the command prompt and give the same command, ping 192.168.1.2. I will see something is happening. Yes, something is happening. All right, which means this machine is able to connect with 192.168.1.2. Where is 192.168.1.2? It is available here. So this machine has a IP connectivity with this other end device through the switch. We can check the vice versa also, because in networking there is a statement, the forward connectivity does not guarantee you the reverse connectivity. All right, so we have to be careful. So let me go to this machine and see whether this machine is able to talk to the other machine. So we'll say ping 192.168.1.1, correct? Is it coming? Yes, now this is working. Now this indicates that the PC1 and PC2, or probably PC0 and PC1, they have the IP connectivity among them. All right. Assume that this is our local area network. Okay, your machine, your home or your office or your institution has this network. It's a simplified one. All right. And there is another network which is existing in the same way. I'll create such another network. What can I go for it? I'll go for a PC here. I'll go for another PC. This time I go for a server. All right. And these three are going to be connected with the switch. Switch is here in the second icon, and I go for the PT switch and I place here. And which icon or which connector I am supposed to use to connect them. It's a straight through cable. I told you to use this automatically choose connection time to start with now. So I go for it. I connect these two. That's working. Then I connect these two devices. I connect these two devices. All right. Now this switch is connected with three end devices. And let me give a network, could be 192.168.5.0 network. Yeah, I'll go for it. Just to remember, I'll give 192.168.5.1 with the mask 255.255.255.0. So that is the IP of this machine. And the server I am giving 192.168.5.2. Then the mask is 255.255.255.0. Okay, so this one 192.168.5.3 with the mask 255.255.255.0. All right. If this is not visible, I'll keep it here. Yeah, this is visible. Why can't we give some name? Probably I can give a name to this. We'll call it as web server. Just for our understanding, we call it as web server. All right. So this is a web server, and we have some machines here, and this is another area. So shall we go ahead? Shall we start assigning IP address to these devices? Yes, we'll proceed. So this machine will be, how will you assign the IP address? Go to desktop, give the IP configuration, you give 192.168.5.1 with the mask 255.255.255.0. Close it. I'll go for this machine. I go to desktop, go to IP configuration, 192.168.52 with the default mask. For the third machine, they are given 192.168.53 to avoid conflict. I have given it. Shall we quickly check up whether they are able to talk to each other before we proceed? Okay, I go to this machine, I give the command 192.168.5.2. Okay, I'm sorry, I forgot to give ping command here. 5.2, is it pinging? Yes, this machine is able to talk to 5.2. We'll check the same thing at 5.3. Yeah, that also works fine. Hope the other conversation also would be correct. Anyway, we can cross check 192.168.5.1. Is it pinging? Yes. So we have taken some samples of pinging, and these are able to talk to each other. All right. Now This is one local area network. We call it as LAN 1. Okay, I'll give it as LAN 1. And this is another network. I can call it as LAN 2. So there are two local area networks. One is LAN 1, the other one is LAN 2, right? Now, how can I make this machine 192.168.1.2 to ping with 5.3? How can I do that? Because they are in different places. Assume that they are not separated physically, maybe 5 kilometers or 6 kilometers away. Or in other words, they are in separate buildings. How can I make them to talk to each other? This is one local area network. This is another local area network. How can I connect? Can I go for a switch? If I go for a switch, can we go for a switch? Yes, I'll tell you whether you can go for a switch. We can place a switch, but there is a characteristics of this switch I wanted to recall now. Switch is a device which is to connect networks, which is to connect same networks. What does it mean? If a switch is connected to 5 devices, all the 5 devices should have the same network address. If you do not know what is a network address is the address which represents a network. What is that, sir? How can I calculate? You can calculate by taking your IP address and then go for AND operation, logical bitwise AND operation with the mask, and the result will be your network address. For instance, let me go through quickly. You got 192.168.1.1 with the mask. So when you take these two, this is the network IP address, this is a mask. When you go for bitwise AND operation, because both of them are 32 bits in size, what will be the answer? Your answer will be 192.168.10. Similarly, when you go for this, you will get again 192.168.10. These two are having the same network address. Now switches are comfortable in connecting these two devices because they belong to same network. Similarly, when you look at the right hand side, you got 3 devices which are again connected through the switch. And if you calculate the network address, you will end up in getting 192.168.50 for all these devices. Again, all these 3 devices belong to the same network, and then you are having the switch. Now, how can I go for another switch to connect 1.0 on one side and 5.0 on the other side? That is not possible, right? When you go for a switch. So what can I do now? I think I can use I can introduce a device called router. Where is that fellow? Yes, router is here. And again, I go for a PT router. So I bring this PT router here. To talk about this router is normally given as a layer 3 device in the OSI reference model from the bottom after physical data link and the network layer. This is in the network layer. And the IP addresses are normally dealt with this router. Routing, which is our core concept today. I haven't taken you to the routing concept yet. So routing again is happening by these switches, and firewalls can be implemented here. Filtering is happening here. Authentication can happen here. It can do a lot. It also uses the port numbers for applications for different routing protocols. So this is a big fellow. All right. So this router has one of the characteristics that it can connect different networks. That is to say, the routers cannot be used to connect devices of same network. In other words, in this configuration, this switch cannot be replaced by a router because these two belong to same network. You can't use a router to connect these two. All right. So now, don't you think this router is a best option now to connect network of two different networks? This is going to be 192.168.1.0. This is going to be 192.168.5.0. All right. Now, these two networks can very well be connected with this router. How can I connect this router? Yes, you are correct. These two switches can be connected with this router. Again, we'll go for this automatically choose connection type. So I connect these two. Do you see? Yes, there is a connection. It connects these two. And again, these two are connected. Now in the packet tracer, it gives you some red color or green color. Red color says the IP connectivity is not yet done. Green color says, yes, it is perfect. It is working generally. Okay. Now, how can I make it red color? Yes, I'll tell you how we can do that. For that, I'll tell you to do one thing. Go to the switch and go to the config tab. In the switch, if you go to config tab, this is actually fast Ethernet 01. Okay, FA01 means fast Ethernet 01. Where is it? This is fast Ethernet 01. Okay, then you got 11, 21, 31, 41, 51. So there are 6 interfaces: 01, 11, 21, 31, 41, 51. These are the names of the interface. All right. So if I go to fast Ethernet 01, by default in the switch, you can see the port status is on. Okay, yeah. You can see the port status is on by default if you go to any interface. What is the meaning of port status? Whether the interface is administratively available, whether a traffic can go through that interface or not. If a traffic can go through, which means if the port status is off, traffic cannot go through, packets cannot be sent and received through that interface. If it is on, yes, it is possible for you to send and receive. Very simple. Now look at the router. You have got FA00, fast Ethernet 00. I go to a router, go to config, go to fast Ethernet 00. You could see the port status is not on. So you have to make it on. Just clicking this button. Do you see this becomes green? Yes, it becomes green, it becomes amber. Let's wait for some more time. These both will become green. All right. Similarly, fast Ethernet 10 in the same router, go to config, fast Ethernet 10. You have to make this on. Now this has become green. Okay, so you could see these two have become green. Now you see the physical connection is perfect among these devices. So are we ready? Shall we try to ping the devices? Okay, so from 1.2, we are going to ping 5.3. That is our objective. Yes, you remember that well. We'll go to command prompt. I give ping 192.168.5.3. Does it work? It's pinging. It's trying to ping. Is it coming? Is it coming? Oh no! It says request timed out. Anything else? No. Still request is timing out. I don't have a hope. Okay, I don't have a hope that you will get a ping after even this many timed out. So something wrong is happening. All right. Now this is a end device. You got an IP address. This is another end device. You got the IP address. Similarly, these end devices, you got the IP address. You got an intermediate device. Okay, switches. I said they are connecting same layer, same IP, same network devices. They don't require IP addresses. But don't you think this router is connecting to different networks, and this router also needs an IP address? Okay, so the routers have to be assigned IP address. That is our decision now. How can we assign IP address, or how many IP address do they need? Well, now in this example, this router needs at least 2 IP addresses. For what? All right. Now assume that this router is a translator. You can see somewhere, one person is standing in the middle. Assume that there are 2 people. One person knows only Telugu. The other person knows only English, or maybe probably Tamil. All right. This person can only talk in Tamil. The other person knows only Telugu. These 2 cannot talk to each other, and now they need a translator. Okay, or probably intermediate person. That intermediate person comes, stands in the middle, and he is trying to translate between these 2. When he is trying to translate, don't you think the person who is standing in the middle should know the language of both? Yes, so he should know Tamil as well as Telugu. Then only he'll be able to talk to each other. Now, on the left hand side of this translator, standing the Tamil speaking guy, on the right hand side the Telugu speaking. For the Telugu speaking, when he is talking in Telugu, he should be able to understand it and then translate it and send to him in Tamil. Similarly, the reverse one. For the Telugu guy, he feels there is one more person who knows Telugu. Actually, there is only one person. All right. For the Tamil speaking guy, he feels that there is one more person who knows Tamil. So for him, he feels I am part of it, part of him, his language. And the other person who is on the right hand side, he thinks I am part of him. Same logic you have to apply here. Now you got the router here. For this router, you have got 2 interfaces which are connected. One is fast Ethernet 00. The other one is fast Ethernet 10. Now, fast Ethernet 00 has to be part of LAN 1. I repeat, fast Ethernet 00 has to be part of this network called LAN 1. Similarly, fast Ethernet 10 should be part of this network. All right. So how can I do that? What is the network address? If you remember correctly, yes, 192.168.1.0. Do you remember that? All right. So I should give an IP address to fast Ethernet 00. It could be 192.168.1.3 because 1.2 is here. 1.1 is here, 1.2 is here. I can give 1.3 or 4 or 5 up to 1.254. I can give any of these IP addresses to this machine. Similarly, can you guess what could be the IP of FA10? It should be 192.168.5.4 or 5 or 6 up to 254. All right. So we'll continue. I go to this machine router, go to fast Ethernet 00. Where is fast Ethernet 00? Yes, fast Ethernet 00 is here. I give the IP address 192.168.1.3. All right. I have assigned the IP address. Done. Yeah, same router. I'm sorry. I go to fast Ethernet 10. For 10, where is 10? 10 is here. So I should give something like 192.168.5.4 or 5 or 6. I'll give 4. Right? Default mask is 1.255.255.255.0, and now it's done. All right. Now can we check whether this machine is able to talk to this? Anyway, for our remembrance, I give the IP address here 192.168.1.3 with the mask 255.255.255.0. Similarly, this interface is 192.168.5.4. Yes, 255.255.255.0. Okay, so this machine is 1.3. This interface, I'm sorry, and this interface is 5.4. I go to this machine and I go to command prompt. Okay. Okay, I'm sorry. Yeah, I go to command prompt and I give ping 192.168.1.3. Is it pinging? Yes, it is pinging. What does it mean? This machine is able to talk to 1.3. Just check on the other side whether this machine is able to ping 5.4. Working? Yes, great. That also is working. So what have we found? This machine can talk to this machine as well as this side, his side, okay? Telugu or Tamil, that side. Similarly, this machine can talk. Shall we, from this machine, try to connect to 5.4? Where is 5.4? In the same router. Okay, go to this machine, go to command prompt. Instead of 5.3, I'm sorry, 1.3, I give 5.4. That is 5.4. 5.4 is here. Okay. From this machine, I am giving 192.168.5.4. We'll see whether it pings. No, that is not responding. I don't have a hope to move. Similarly, if I type from 5.3 to 1.3, we are going to get a similar result, that you are not going to get the ping successful. So what could be the reason? Now please understand the story which is behind this, or the logic behind this. Now this is 1.2, 1.1, 1.2, 1.3. All these fellows are in the same local area network. Okay. But where is 5.4? 5.4 is not, if you assume this is Tamil, this is Telugu. 5 dot is not Tamil. Similarly, 1 dot is not Telugu. So for this person, he will not know where 5.4 is present. Similarly, for all these people, they will not know where 1.3 is present. Okay. How can you solve this problem? Have you got the problem? I tell you, the problem is this machine is able to reach wherever 1 dot is available, because he can ping 1.1, he can ping 1.3, but not 5 dot, because 5 dot is another network for him. Similarly, for him, 1 dot is a remote network. So ping will surely fail. Anyway, we can check that up also, whether we are able to ping 5.4. uh, 5.4, I'm sorry, they're able to ping 1.3. 1.3 you should not ping, you cannot ping. Okay, because 1.3 is this side. For him, he is somewhere else. So it's not going to be successful even if you try multiple signs. Now, this gives you some idea that something has to be done. What can be done? We have to tell these end devices one instruction, because what's happening so far, it looks as the target network, it is one dot. Whenever you got one dot, it sends it because it is available in the same local area network. When it is having the network address as 5 dot, it does not know where it is, so it drops the packet. Okay, it's not going to forward it anywhere. It does not know. I don't know, sir, I don't know where 5 dot. And all these people will say, I don't know where is 1 dot. That's the problem. Now, don't you think if we tell these people that if you have a packet to a remote network, forward it to your router. I repeat, if you have a packet with the destination address, which is not your local area network address, then forward that packet to your router. We call it as a gateway. In other words, it's the default gateway. Okay. What is the default gateway? Please, sir, understand it. If a packet is traveling from, suppose I'm sending a message to 5 dot, I'm telling this machine, hey, if you have a packet to 5 dot, you better send to this fellow. Who? 1.3. Who is 1.3? One side of this router. This router knows both fellows. He knows both languages, right? So he knows 1.3 and 5.4. Which, in other words, this router knows where is 1.0 network, where is 5.0 network. Hence, if you tell this router, he will take care of forwarding it to the other person. All right. So what am I going to? I go to the switch end device once again, go to the IP configuration. There is something called default gateway. Did you notice that? Yes. In the default gateway, I'm saying default gateway is 192.168.1.3. Who is that 1.3? That 1.3 is this IP. The meaning of this is, if you have a packet not designated or destined to your local area network, forward it to this particular IP. That's all. You can keep quiet. He will take care. Similarly, can you guess what could be the default gateway for this machine? Yes, you have guessed it correctly. It is 1.3 again. Same. Okay. So for these two machines, if they have anything to be sent out to the remote network, forward it to this place. Don't you think we should educate these people also? Yes, we have to educate. Now you can help me in giving the default gateway. Yes, you have said it rightly, 192.168.5.4. Correct. That's right. So that configuration is done. I go to the server, same IP configuration. I give the default gateway as 5.4. Done. I go to this machine, IP configuration, default gateway is 5.4. It's done. Okay. Do you think now things are all right? Appears to be all right. We'll see anyway. So I go to this desktop, go to command prompt, and I'm trying the same thing. What is that same thing? I'm trying with 5.4. It's working. It's working, right? See, earlier you tried with 5.4, it was request timed out. Now it is working. So what do we think? Why can't we try with the 5.2 from this mission? Okay, from this mission we'll go to 5.2. Go to command prompt. 5.2, is it working? No, it's not working. It's working. Successful. All right. So that also works. And even if you try with all this machine to any of the other machine, now these end devices will be able to talk to each other. Have we learned dynamic routing? No, sir. We haven't started even learning dynamic routing. So far, we have found that this is how the connectivity is. All right. Now, what am I going to do? Which you may not like it. I'm going to delete this. All right. I'm not going to have these two devices. What am I going to do? Instead of that, I'm going to use two routers. Okay, and I'm going to connect one local area network with another router. I'll finish my configuration so that you can understand it clearly. Anyway, for our benefit, I go for switch. I'm not going to use the router here. I'm going to use a switch. So please allow me for a while. I'll connect these devices quickly. All right, so this is a logical topology. So this is switch 1, router 2. So I have used 2 routers. All right. And how many local area networks? Can you guess how many local area networks we have? This is one local area network, LAN 1, LAN 2. Okay, probably I will keep it like this for your understanding, or probably I will put it like this. Yeah. So this is LAN 2. And we have got another LAN. How do you say that's the LAN? Yes, you have got a switch which is connecting. All right, so I can call it as another local area network, that is LAN 3. I put it as LAN 3, right? And we can start assigning IP addresses. So this configuration is little tricky, all right? So for our understanding, I'm going to help you what are all the IP addresses we are assigning, so that you will not be confused, because I have only 15 minutes more to go. I'm going to give the IP address to this like 192.168.1. Probably 3 with the mask. Mask is 255, 255, 255.0 for everyone. So I'm not going to give the mask anymore. This is going to be 192.168.2.1, which is 2.1 serial 20. This is 192.168.2.2 because that is, I'll tell you why I have given same 2.2. So this is going to be 1, this is going to be 2, probably this is going to be 3. 3.1. 3.1 is here. Then 192.168.3.2 is here. 192.168.3.3 is here. Okay. And what is this IP? If you remember it correctly, it is, can you recall, 192.168.5.4. Okay, that is this IP. Hope now you can get some logic. This is probably, I call it as a DNS server for our understanding. This is a DNS server. I have given the name, another personal computer. All right. So now what's happening? You have got LAN 1 here, LAN 2. There are 3 LANs connected through 2 switches. So this routers. This router is connected to a LAN. This router is connected to 2 LANs, and there is a WAN. This is a WAN connection, wide area network connection. Okay, so I call it as WAN. So yeah, okay. This is a WAN connection. Now you could see there is a red color light. It's not green color. Do you remember what we have done to make it green? Yes, go to switch, go to config, make that interface fast Ethernet at switch on. Yes, you are remembering it correctly. Then go to the FA0 switch, 0 port, switch it on. Starts greening. 1.0 becomes green. Yes, we have done it. We have made it as green. What else should we do? This should be, this is already given IP address. This is already given IP address. But all these devices have not been given IP address. Hope you remember it. All right. Now go to this switch, and for the fast Ethernet we have to give FA00. So go to this switch, fast Ethernet 00, FA00. What's the IP? 192.168.1.3. Mask is 255.0. Here it is 5. So go to this router FA00. It should be 192.168.5.4. Have we done it correctly? 5.4 with the mask as 255. All right. This I said we are going to give 3 dot. Okay, so this should be given 3.1. So I'll keep it here so that it will not create confusion. So for FA10, go to the switch again. FA10, that is fast Ethernet 10. I'm giving 192.168.3.1 with the mask. Right? So let me finish assigning IP address to this device. What is the IP address? 192.168.3.3. Go to the desktop, IP configuration, 192.168.3.3. Mask is this. Gateway, can you guess what is the gateway here? 192.168. Yes, 3.1. That should be the gateway. And I'll assign IP to the server also. I have called it as a DNS server. I'll go to this. So 192.168.3.2. And what's the mask? What's the default one? 192.168.3.1. That's the default gateway. All right. So I think we have given IP address to this. What is pending? What is left is these two interfaces. That is this serial interface and this serial interfaces. These two are pending. Before that, just to have a quick look whether we have given the proper IP addresses, you can bring the cursor over it. Is it 1.1.255? Yes, 1.168. Is it 1.2 and 2.161.2? True. What about this router? 1.3 is given FA00, 1.168.1.3 FA00. Perfect. Whether it is given two IP addresses, 5.4 for 00 and 3.1 for 10. 3.1, 1.0, 10, right. For this one, is it 3.2? Yes. Is it 3.3? Yes. Perfect. Coming here, is it 1.5.1? We have given it already, but anyway, 5.1. Is it 5.2? Is it 5.3? I missed to check whether the gateway is given 3.1. Is it given 3.1? Yes. All right. So configuration on these local area networks are perfect, and they are connected with the routers interfaces. That also is perfect so far. Something is pending. What is that pending? The WAN connection. All right. So when you look at your configuration, when you compare with the configuration of your fast Ethernet, WAN connection require one more configuration. I'll tell you what is that one more configuration. For instance, I'll go to serial 20. Serial 20 is 2.1. So go to this machine, serial 20. I make this on, and I give 192.168.2.1 with the mask. Okay, and you should set the clock rate. Okay, so clock rate probably you can give 64,000 for instance. Right. So this one you should remember to give the clock rate. So I go to this router and go to the serial interface, serial 20, switch on. I'll give 64,000. So 192.168.2.2. Yes, and the IPs are given. You could see this is low. This has become green, and we can check the IP connectivity now among 1/2 distance. What is the 1/2 distance? From this machine, when I connect with the router, am I able to ping? Similarly, between the routers, am I able to ping? If I'm able to do that, my basic configuration is done, and we are ready for our dynamic routing configuration. All right, so let's proceed. So from this machine, let me see whether I can ping 1.3. What should I do? I should give 1.3. It's pinging. Let me see whether I'm able to ping 2.1. It's pinging. From this router, I'm going to see whether 2.2 is pinging. For that, I'll go to CLI. I would recommend you to learn CLI because I don't find time to teach you the command line interface now. If I'm permitted, probably in a later session, I'll take you through this router CLI command, but it will really take a little more time to learn. So I haven't explored the CLI as of now, but just using it to see whether it's able to ping. Okay, from this router, let me see whether I'm able to ping 3.3. Yes, that is also perfect. It pings actually, right? So probably from this machine, let me see whether I'm able to ping 2.2. Ping 192.168.2.2. Pinging, whether everything is perfect. It's working. Yes, it's working. We'll see it again. Yes, it comes. All right. Now what happens? Every machine, see, this machine is able to ping this router. These fellows are able to ping this router. These fellows are able to ping this router. These routers are also able to ping to each other. Now, don't you think this is perfect? Why can't we try whether this 1.2 is able to ping 5.3? Shall we try from this machine? I give 5.3. Where is 5.3? 5.3 is here. 1.2 is here. Let me see whether this machine 192.168.1.2 is able to ping 5.3. Okay, you got a different response now. It says destination host unreachable. Where do you got the response from? 1.3. Who is 1.3, sir? Do you remember? Your gateway. So your gateway router says, sorry boss, I do not know the destination host. That's a little trouble, right? What's the other meaning? What's the meaning of this statement? This router has no way to connect to 5.3. In other words, probably it does not know how to reach 5.3. That's the tragedy. Now, we need to do something on this router. That's the core part of today's session. Don't worry, I'll finish it in probably 10-15 minutes max, not more than that, right? So we are going to do something called routing. What is that all about? Assume that this is a person from one city in Tamil Nadu. This is the person from a city in probably Andhra Pradesh. Okay. All right. Now this person from Andhra Pradesh is connected with Vizag and Kurnool. Just an assumption. Okay. And this person in Tamil Nadu is connected with Chennai. All right. Now he knows how to go to Chennai. You got it? And this person knows how to go to Vizag as well as Kurnool. Andhra Pradesh or Telangana, I don't know, but this earlier it is Andhra Pradesh. Route. So how can I make this person to know about Vizag and Kurnool? How can I make this person to talk about Chennai? Who can do that? These two routers, all right? These two fellows. Okay, the person from Tamil Nadu has to share his knowledge. In other words, he has to share his routing information about Chennai in this example to the person who is in Andhra Pradesh. Similarly, the person in Andhra Pradesh has to tell about this information to him. What's the other meaning? Sir, this person can say, bro, if you need to go to Chennai, just talk to me. I will guide you. I will take care of you. Or if you have anything to be given to Chennai office, forward to me. I will take care. Similarly, this person has to say, if you have anything to be given to Vizag or you have anything to be shared with Kurnool, you forward to me. I will take care. Then don't you think these two people will be slightly relieved? And now this person knows where is Vizag. This person knows where Kurnool is. And again, now he also knows how to reach Chennai. How to reach Chennai? All he needs to know is, no problem, boss. If I have something to send to Chennai, I had to only forward to my friend who is here. Similarly, now he is from Chennai, or he knows how to go to Chennai, is now has the confidence and he knows how or where he has to send his information that it will reach Vizag or Kurnool. Assume that he has something to send to Vizag, he has to tell to him. Now, how can it happen? These two routers in this technology, in this networking, has to share the routing information. So initially, the left-hand side router on the screen knows only one route or only one network, and the other person knows two networks except the wide area network. I'm not talking about the WAN connection now. I'm talking about only LAN connection. Okay, so this left-hand side router here knows only LAN 1. Right-hand side router knows only LAN 2 and 3. When they talk to each other and exchange the routing information, now router 1, the left-hand side router knows LAN 1, how to go to LAN 2, how to go to LAN 3. Similarly, the right-hand side router in this topology knows how to go to LAN 2, LAN 3, and now LAN 1 as well. All right. This is called routing information exchange. All right. And the topology is converged. Now, who is responsible for it? It is the routing protocol. Okay. So dynamic routing protocols play a major role in this. There are different varieties. We have got static routing. We have got dynamic routing. Little bit of default routing as well. I'm not going to talk about that. Static routing, where you have to go to every router, configuration for every network. When you go for dynamic routing, there are multiple varieties of dynamic routing protocols. They are divided into two major categories. They are distance vector routing protocol and link state routing protocols. All right. Routing information protocol version 1, version 2, EAGRP. These protocols are known as distance vector routing protocol, whereas link state routing protocol, ISIS, all these are known as link state routing protocols. So today's session, for another 5 to 10 minutes, I'll be talking about how to configure RIP protocol, and we are going to see whether the exchange is happening. Shall we go ahead? Right. So how am I going to configure RIP protocol? Please remember the logic. Every router has to talk about his knowledge to others, similar to gossiping. Okay, whatever I know, I'm sharing with him. Whatever he knows, he'll be sharing with me, so that we both have the same knowledge. All right. Similarly, here routers are exchanging their routing information. They exchange their known networks. What is that known network? In other words, it is initially it is talking about the connected networks. Okay. Let me go to R1. So to avoid that confusion, I call it as R1. This is going to be R2. Sorry. So this is going to be R2. So R1 and R2. R1 is connected with two networks. What are those? 192.168.1.0 LAN network, 192.168.2.0 WAN network. Do you understand? Because this router is connected with two networks. You could see this link. Now in that angle, can you guess about this router? How many networks it is connected with? Yes. Yes, right. So it is connected with LAN 2, LAN 3, two networks, and also a WAN network. So there are three networks. This router is connected with three networks. So what is going to happen in the dynamic routing protocol? We are going to these routers and we are going to tell this router R1, listen, you are going to advertise. Okay, you are going to advertise about 1.0 and 2.0, and go to R2 and we are going to tell him better advertise 3.0, 2.0, 5.0, 3.0, 2.0, 5.0. Once you are making them to advertise, they can exchange this information and they'll be able to converge at the end. Now 192.168.5.3 is unreachable. From this network, from this device, 5.3 is unreachable. So we are going to do the dynamic routing protocol configuration. Go to this router. Don't worry about this command now, but get the logic now. Config T, configure terminal. I'm going to configure routing protocol called RIP, routing information protocol. And what are all the networks it has to advertise? 1.0 and 2.0. So the command is network All right, so I have made this router to advertise about 1.0, 2.0. What about this? This person has to talk about 2, 3, and 5. So go to this router, config T. I give router RIP, so network 192.168.2.0, 3.0, then 5.0, right? So in packet tracer, you can see that in config as well. In the RIP, it will be available 2.0, 3.0, 5.0. And let's allow this network to converge. Converge means they exchange some routing information. Now we'll see whether things are fine. Yes, it's pinging. Did you notice that? Yeah, earlier the same command, it says network was unreachable. Now it is able to ping to each other. All right. Now we have learned how to configure RIP protocol. It is called RIP version 1. We can learn about RIP version 2. We can learn about AGRP, OSPF, and ISIS probably in another session. In detail about IP addressing in another session. But before I close out, why can't we see why did I install this web server and DNS server? Some interesting portion which is available in the packet tracer, maybe for another few moments. So I make this machine 192.168.5.2 as a web server. So I go to this machine. Do I have the services? Yes, it's here. I make it as HTTP. It is on. All right, it's available. What's the IP? 192.168.5.2. I go to DNS server. And in the DNS server, I'm going to configure DNS like it is. So what's the name? Probably www.webserver.com. And what is the IP? 192.168.5.2. Okay, I have added it into the DNS. So what's the IP of DNS? It is 192.168.3.2. So go to this machine. 3.2 is the DNS. So I give 192.168.3.2. Okay. So what was the IP I gave? Webserver.com. So I go to this machine. Go to this machine. Where is browser? It's here. I give www.webserver.com. Yes, you got the web page available here. Okay, I stop here. But just to say you how it is working, I'm going to the simulation mode. Probably last few minutes, the simulation mode. I'm going to filter out all. I'm going to use all this. Show all, I give show all or none, and then here what do we need? I need probably HTTP packet. Where is DNS? Do we have DNS here? Could you see DNS? Yeah, I need TCP and DNS. Okay, I think these three packets are sufficient. So I go to the simulation. Here I'm going to type webserver.com and I press go, and you could see what is that packet. A DNS packet is running. I allow this to go. It has to go to DNS server to get the IP back. Then your TCP packet will be there. It will go and establish. This is called TCP handshake protocol, three-way handshake protocol. And along with that, you will have your HTTP packets piggyback. And till now, you won't get anything response. As soon as the wallet packet reaches here, you will get the response here. All right. So I stop here. This is just to demonstrate how your TCP, your DNS, or UDP, your HTTP, these things are working. Very, very interesting tool. Hope I have taken you probably a full round of what are the different aspects available in this tool. So I encourage every one of the participants to make use of this Cisco Packet Tracer tool to enhance your skills on computer networking. So today I have taken you through the dynamic routing of RIP version 1 protocol. Hope this session would be very useful to you. If at all you want to talk to me or for any assistance on this, you can connect to me through my email, that is immanueljohnraja@gmail.com. IMmanuelJohnraja@gmail.com. So I welcome and I wish you all the best during this pandemic. Stay alone, stay safe. God bless you.
Thank you for your wonderful presentation, sir. Participant, if you are having any query or doubt, contact our resource person through email using the ID immanueljohnraja@gmail.com. So it's a time for vote of thanks. Greetings to all. On behalf of St. Mother Teresa Engineering College, I take this opportunity to propose vote of thanks. First of all, I would like to thank our resource person, Dr. J. Immanuel Johnraja, sir, for his excellent presentation and making this webinar interesting and meaningful. We are really elated with your knowledge and presence, sir. Thank you, sir. Next, I would like to thank our principal for enthusiastic support and motivation. Thank you, sir. Next, I extend my thanks to our head of the department, Mrs. Bhimajan Sahin ma'am, for her support and coordination. Thank you, ma'am. Finally, our heartfelt thanks to all the active participants for their participation. Thank you all.